Welcome back to Chem Talks. Today we are going to start looking at more depth into the electrons. We've talked a little bit about protons and neutrons. Now it's time we talk about neutrons. Even though they're very small, have a very low charge, and weightless, they are very important to the atom. It's going to help determine most of the characteristics of an atom. Before we start talking about electron, I want to go ahead and review some of the models of the atom that we talked about already. So let's go ahead and do those, and we'll get into the electron. Okay, remember the first person to come up with a model of the atom was J.J. Thomson. He had the plum pudding model. The plum pudding model said there was a proton with a mass of electrons spread through it. We talked about being like cookie dough, where the chocolate chips are all mixed in. Okay, so he had the idea of positive and negative charges, but he was off. The next person to come in was Rutherford, and Rutherford proposed the idea that there was a nucleus which contained the protons and neutrons, and then the electrons were surrounding that nucleus. They were on the outside of it, so they were more separate rather than mixed together like Thomson. And then the person who almost got it right, or totally right, was Bohr. Remember, Bohr proposed that electrons were arranged in these concentric paths, or these orbitals around the nucleus. And this is really close to being correct. Now, what has happened since then is that Schrodinger has come by and defined it even a little bit more to give us our current understanding of it. Basically, what Schrodinger did was explain the location of the electrons within an atom. It was a little more specific than Bohr. He came up with this big long equation which mathematically turns into these different shapes. Okay? Don't worry, we're not going to worry about the equation, but we're going to worry about what his ideas led to and how they led to the understanding of our electrons. So let's talk about electrons real quick. Remember, electrons are found within these orbitals or energy levels around the nucleus. So they're outside the nucleus, they're separate from it. Okay? And the electrons are going to occupy different levels or different orbitals based on the amount of energy they have. The more energy a particular electron has, the farther from the nucleus it's going to be found. The less energy, the closer it's going to be found to the nucleus. Okay, Schrodinger gave us what's called the quantum mechanical model. Okay, this is our modern description of electrons and atoms. Okay, and what Schrodinger basically said is that the motion of electrons around the nucleus is not a definite path. Okay, they're not a definite orbital. Instead, they talk about the electron in terms of probability. Where is it probably going to be found at any one given time? Okay, so it describes the location where an where an electron is most likely to be found. Okay, and we are still describing this location as an orbital, or more accurately, as a sublevel. Okay, and it's this motion of these electrons around the nucleus which is creating this electron cloud that we've already talked about. Okay, and it's the electron cloud that gives the atom its size and shape to the atom. Okay, it gives it its size and shape, so it's kind of important to it. Okay, when we start talking about electrons and the quantum mechanical model, what we're talking about is electron configuration. And this is simply a shorthand description of how electrons are arranged in the atom. Okay? And this is really important because it can help predict the chemical behavior of a particular atom or an element. Okay? It can predict whether two elements are going to react with each other or they're not going to react. And if they do react, it can tell us what type of reaction they're going to have with each other and how strong a reaction this will be. So this is going to be really important as we go on this semester and start talking about atoms and elements interacting with each other. So, as we said, the electron configuration explains where particular electrons are located within an atom. Okay? And remember, their location is based on the amount of energy they have. The more energy they have, the farther away from the nucleus. The less energy they have, they are closer to the nucleus. You can kind of think of electron configuration as an electron's address. Now think about your address, right? It goes from very broad into more specific, right? You live in the United States of America. You state of Colorado. City of Loveland, You're going to live on First Street, and then maybe you're going to live at 2236 First Street. Okay, so it gets more specific, and that's what the electron configuration does. It gives it the house address or the location of an atom, but it also tells you how to get there. Okay, and it's made up of 4 parts, what we call quantum numbers, and the quantum numbers are going to describe the location of the electron. 4 quantum numbers are what we call the principal quantum number, the orbital quantum number, the magnetic quantum number, and the spin quantum number. We'll talk about what each of these means here in just a minute. But first I want to talk about quantum numbers in general. So quantum number simply describes the sublevel, a particular sublevel that an electron occupies in terms of 4 things. It describes it, how far is it from the nucleus, what's the shape of the sublevel, what's the position with respect to the 3 axes in space, and then finally, what direction does the electron spin? Does it spin clockwise or counterclockwise? Okay, the principal quantum number, our first one. This gives us generally the most probable distance the electron is from the nucleus. It's what the main energy level designation. Okay, this tells us how far it is from the nucleus, and its principal numbers can be 1 to 7. 1 is closest to the nucleus. 7 is the farthest away from it. And what we see is these quantum numbers correspond to the rows or the periods of the periodic table. So if we look at a periodic table here, this would be principal number 1, principal number 2, 3, 4, 5, 6, and 7 as we go across. So it's really easy to know what your principal quantum number is, the same as whatever period you're in. The second one is the orbital quantum number. Now, orbital quantum number indicates the shape of that sublevel or that orbital. It has a specific shape. And there are 4 basic electron orbitals, or 4 basic shapes. We have what we call the S, the P, the D, and the F. And as we see, as we go down this, they have increasing energy levels, with S being the least energy and F being the highest. And what we see is that each of these orbitals has its own unique shape. The S is kind of a spear, like a ball. The P we can think of as a dumbbell, okay, in shape. Think about lifting the dumbbell, the shape of that. The D reminds me of kind of like an iron cross almost. And then the F looks like a jack. If you were to play Jack, the game's Jack, it looks like the jack on this. So each of them have their own shape. And as we build this orbital, kind of nest it in or around one another. If we look on the periodic table, if you're in column 1 or 2, you're going to be in an S orbital. If you're over here, you're going to be in the P orbital. In the middle here, you're going to be in a D orbital. And then finally, down at the bottom, you're going to be in an F orbital. And this is going to be really important as we start writing the electron configuration to know, are you an S, P, D, or F? Okay, what we see when we're talking about these sublevels, there's many sublevels or orbital shapes as the quantum number that you're in. So look at this chart here. If you're in the first period, okay, you have quantum number, principal quantum number 1, you're going to have one shape, and that's going to be the S. As you move down one row, you're going to have 2 shapes. You're going to have S and P. Move down to the third row, you're going to have S, P, D orbitals. Then if you get down from 4 to 7, you're going to have 4. You're going to have the S, P, D, and F. This will start making a little more sense as we start doing some practices. So just kind of get these notes down now, and we'll do some practice later here. Okay, the third quantum number is what we call the magnetic quantum number. A magnetic quantum number basically tells us what's the position of the particular orbital, or the shape, about the 3 axes of space, the X, Y, and Z. And what we see, depending on if we're talking S, P, and D, or F, they're going to have different positions that they can occupy, or different numbers of them. So let's take a look at that right now. So each orbital position can hold 2 electrons. Okay, so S, it's a sphere. No matter how you turn it, it's basically the same thing. So it only holds one position for a total of 2 electrons. P, which is our dumbbell, remember, can actually be 3 ways on the X, Y, and Z. Okay, so it has 3 positions. Each position can hold 2 electrons, so a total of 6 electrons in P's. D, that's kind of our iron cross, has 5 different positions it can occupy to hold a total of 10 electrons. And then finally, F has a total of 7 positions for a total of 14 electrons. And these are going to be important to know. And as we look at our periodic table, if you go back a little bit, you can see the S was column 1 and 2. The P's are the 6 columns on the far right. Each column is a different electron. Our D's were in the middle section, where there's 10 boxes there, 1 for each electron. And the F had 14 going across. So you can kind of see how they relate there. The next quantum number is what we call the spin quantum. That's our final one. And spin quantum number simply indicates what direction are the electrons spinning about those orbitals, or these axes. Are they spinning clockwise or counterclockwise? And what we see, remember, each orbital is going to hold 2, and the electrons on those orbitals spin in opposite directions from one another. All these quantum numbers, all 4 of them, can be put into mathematical terms. We're not going to worry about that for basic chemistry. When you take AP Chemistry, you will start assigning values to those. What we want to be able to do now with these quantum numbers is to write the electron configuration, or the address of the electron where it's found around the nucleus. So that's what we will do in the next video. Until then, guys, we'll talk to you later. Take care.